There we go. Fantastic. All right. So the very last thing for today is looking forward at test beds. We've heard about the experiences of test beds and the experience, but let's talk about where we're going next. So we should introduce ourselves, and then we'll go into the topic. So again, I'm John Chapin, Special Advisor for Spectrum at the National Science Foundation, and Program Officer for Cognizant PO for the NERDS program. Go ahead.
Good afternoon. I'm Paul Ransom. I work at the Office of Spectrum Management at NTIA.
And I'm Michael Cotton. I'm Division Chief for the Theoretical Division at the Institute for Telecommunications Sciences in Boulder.
Could you bring the mic a little closer to yourself?
Oh,
sure. That also was a good audio check. Okay, so asked each, I'm part of the Fireside chat, so I've asked each of us to prepare a short initial statement. And for Mike, we were going to ask to hear about the existing ITS test beds, including Table Mountain, and what's going on with FACS, and anything else you want to talk about.
Okay, thanks, John. Yeah, so, you know, I really appreciate the opportunity, John and Chris. I have to admit, I underestimated what has been done here in the NERDS zone area of research, and it's really been impressive. But at ITS, we're the Institute for Telecommunications Sciences, and we're a matrix organization that are divided into core disciplines of theory, measurements, software, and systems engineering. And we run the Table Mountain Radio Quiet Zone, which is the only radio quiet zone that allows for open air transmissions. We work with agencies and industry partners to characterize and test different systems and spectrum sharing technologies there. So in recent times, I guess the biggest event that happened there was the 3.7 to 4.2 gigahertz radalt 5G testing. I think that was in 2022. And we have sort of longer partnerships that have occurred there. So for example, we've partnered with NOAA to apply some dedicated research on their 1.7 gigahertz RF interference monitoring system, or RFIMS. So we have a number of facilities that are established there at Table Mountain, and we work with those systems directly. Now Table Mountain has been rebranded recently as the Federal Advanced Communications Test Site, or FACS, and that has come with new funding that has started this year. And so there's some serious alignment with the National Spectrum Strategy, where we're kind of expanding the facilities that are there, where we're working on them directly. We have a real focus on the characterization of these more advanced systems, also on really getting into measuring the interference of into these systems, because if you have some ownership, you get to plug in, you get to measure the signals in different spaces, and really, sometimes we go out into the field and we go to these sites where these systems exist, and the testing can only be for a week or something like that, because that's the only time that it's available. And so it's really a good thing to have sort of a dedicated resource there to apply there. The other thing that's going on with FACS that's new is, and John, I just learned, you might think this is mixed messaging, but I just read it in full yesterday, but there is a plan to have a continuous long-term monitoring network there on Table Mountain under FACS, where the data acquired is curated and managed and made available to authorized government and non-government researchers. And I just maybe want to do a quick plug for the ITS Spectrum Monitoring team, who has demoed the ITS developed system that we standardized under IEEE, and they had that over. I guess it's gone now, but they had it in the demo room over there. And the last thing I just wanted to mention really quick is we do have close relationships with the FCC. where just in terms of sort of maturing spectrum sharing technologies, we help the FCC develop certification tests for spectrum sharing technology. So for CBRS, for example, we actually WinForm developed the test platform for the spectrum access system, but we took it over and provided test parameters and then ran the tests for the SAS. Also, which is a little bit closer to our main function or our main capabilities, we also set up an emulated signal environment to do some tests on the ESCs. And so what we do after we kind of go through the first and second round of testing, I think we went through the first 2 rounds of testing with the CBRS partners, then we push those tests over to the FCC, and they transition them to certification labs. So we do a lot of test development just in terms of getting these technologies past a bar where they are adopted and scaled out and deployed. And then I think I'll just stop there. Our goal was to be about 5 minutes, so I'll stop there, John.
Fantastic. Thanks, Mike. Now over to Paul. So the question to you was what the National Spectrum Strategy says about testbeds, and in particularly what role NTIA will play going forward. Thanks.
Thank you, John. Before I start, first I want to say, for those that don't know, Institute of Telecommunication Sciences is a part of the NTIA. And so I like to associate myself with all the great things that ITS is doing. And so when you think of all those really impressive, great things that they're doing, think of me too. So I want to be a part of all of that. So, no.
And I'm part of the U.S. government, so I can claim you too.
But I say that in jest, but I also say that the National Spectrum Strategy identified dynamic spectrum sharing as a very important and critical part of the plan for modernizing spectrum use. In addition to the dynamic spectrum sharing, it identified the establishment of what we called a national dynamic spectrum sharing testbed. And as we were thinking about what that meant in the strategy and also in the follow-on implementation plan, we worked with ITS to say, how do we describe this? How do we define what that might be? And in the implementation plan, that's where we try to provide more detail, put more meat on the bones to what that is. So we described it as a network, a federated network, somewhat distributed, of complementary sites. And a part of what that National Dynamic Spectrum Testbed was intended to do was also bring together industry, government, academia to try to identify gaps in our current testbeds and see how we might address those gaps in perhaps this new dynamic spectrum sharing national testbed. So that's a part of what the national strategy says about a dynamic spectrum testbed is we have capabilities, we have testbeds that already exist. Are they missing something that we need to perhaps prioritize in adding to our current existing testbeds? We also talked about in the implementation plan the idea that we'd like to establish this national dynamic spectrum testbed in 12 to 18 months. It was silent on when that 12 to 18 month started, intentionally, but we know we want to do it in the near term, right? We don't want to put something out as an administration priority and then never really get anywhere. And so that's another critical part. We want to have an established dynamic spectrum testbed in the near term that can really start to move spectrum sharing forward in a meaningful way. And I think in order to do that, we've looked at this definition of a complementary network of sites that has identified gaps in current test beds and perhaps identified how we might introduce those capabilities in the existing test beds, or maybe that calls for a new test bed. Well, within NTIA, we would like to play a key role in
Keep going. Keep going.
we like to play a key role in the development of the National Dynamic Spectrum Testbed. But our role, I think, as we've defined it, is more in terms of coordinating the Dynamic Spectrum Sharing Testbed and organizing the testbed and facilitating stakeholders access to those testbeds. And in this case, John Chapin has been very helpful in ensuring that we include academia as a stakeholder in accessing dynamic spectrum testbeds, as well as industry and government. So as of yet, we haven't totally defined what we're going to establish as a national dynamic spectrum testbed, sharing testbed, but certainly NTIA is going to play a key role in organizing and developing the establishment and helping to facilitate access to these testbeds for the broad community. I think that's all I have.
All right. So I'll try to be very quick here. The thing about the very future, the vision of the NEFC from NSF side is that everything NSF does is community-led, community-proposed, right? Just like a major telescope or something. So the process that would go on here is we finish the NERDS program, we get lessons learned from our field trials, the community could decide that's it, we don't need any more of that stuff, and then it's over. If the community wants to go forward, the community could then propose, say, a workshop to define a potential national facility based on those lessons learned. And we would support that workshop, and then the community could come together and some PI or set of PIs would step forward and say, I want to actually be the person to lead this project, right? I'm going to put in a proposal to NSF to build the facility, and here's what it's going to look like. And then that proposal will get merit reviewed like any other NSF proposal. Generally, if the cost is north of $100 million, at that point it goes into a queue that's called the Major Facilities Queue, and there's a special funding line from Congress, and prioritization for that gets decided at the National Science Board level. Maybe it'll be cheaper than that, maybe it'll be more expensive than that. That's all to be decided by the community. It depends on what you want and what you need and what we think for the nation needs. So that's just, my pitch is to be keeping that in the back of your mind as we're going through this process, is that in about 4 years, we're going to ask you to come back and decide if you want an FC, and if so, what it should look like. So I think I'm going to stop there. We have a couple of questions here. It is already close to our 5:45 stop time. I see a hand. Let's give Monisha a chance to drive us in a certain useful direction, and we'll use a few minutes. Yes, thanks.
Thanks. So, I'm still a bit confused as to what this testbed is. So when I think about especially a dynamic spectrum sharing testbed, there are at least two qualities that this testbed should have in my mind. We have to have a way to combine sensing with whatever it is we're doing. When I hear about all these testbeds that have 5G deployed, are those black box 5Gs? If I cannot do anything with that 5G that can change antenna patterns or can change TDD sinks or they can change resource blocks, then I'm very limited in what I can do with that testbed. I can only run it as a black box, and then how do I test dynamic spectrum sharing with that black box? So I truly feel that to have a test bed that is viable going forward, the power approach was let's make them SDRs. That takes tremendously long time to do. By the time you've done the SDR, your 5G has become 6G, and you're behind where the industry is. Some of the power test beds have had 5G given to them by equipment providers, by Ericsson and others, but they're black boxes. So how do we get to a test bed which is state-of-the-art, but is still, you can still fiddle with it. You can still change parameters. 3GPP has got 1 million options. These implementations implement a handful. There are probably many, many combinations that could really make dynamic spectrum sharing work, but we can't even access them. So that is what I'm struggling with as I think about how we really get something out of these test beds in the future.
Can I ask you a question back then?
Sure.
Is there a way that Open RAN could grow to implement that? And if so, what would we, the government, have to do to encourage it to grow in that direction?
So Open RAN is behind it's good. I think there are still, we need the open radio unit. So the NO-4 2 that NTIA has put out, I think is a first step. You need that open radio unit, but it has to be state of the art. It cannot be like, I've looked at, say, OAI implementations of 5G. They implement a very, very small subset of what 3GPP is. It is not state of the art. It does not compare to what a T-Mobile is deploying, which is aggregating 6 channels of 5G. That is what you want to figure out, can you share with that, right? So you have the state-of-the-art deployed commercial systems. Open RAN is not there yet, and I think it would be great to make the Open RAN effort go in that direction.
Why don't you decide? I was going to say, Monisha, pass it over to somebody. Who are you going to pick? It's going to be informal.
I have just a quick response. I think a lot of the progress, and actually maybe I should let. So one of the things that I think should be celebrated about the progress that was discussed today, is what DySPAN recognized too, and that is. It was talked a number of times here too, the repeatability of experimentation, right? And being able to kind of evolve our thinking as we start testing in various ways. So that evolution, I think, should kind of focus on some of the spectrum management models and principles that really need to evolve, right? And I think the community kind of needs to work on that. But I do recognize kind of what Manish is talking about. There is a little bit of a gap here between research, which is really where the testbed, the NERDs are right now, and the outcomes of that research and the adoption of those outcomes. I think that's kind of what you're saying, right? And there is sort of this gap here. And I guess, to me, I think if there's some continuity in this testing, and some repeatability in this testing, that is hopefully where partnerships may come. Maybe there is a need for industry to come and work with a test bed for whatever reason. We've talked about a number of test beds here, and that really is where that gap could close. I mean, personally, I feel like that is where the purpose of the test beds lie, is to move the technology maturation up to something that could be adopted by government agency and industry. Over.
So I just want to react to Manisha, and I agree with Manisha partially. So let me first say I think we do need access to, we need open source or access to, otherwise we can't change it, right? And then the problem is, completely agree with you, well, the open source isn't quite there. But I think the effort should be to get the open source there. So the analogy I've been using or thinking about of late, if you think back, I don't know how many years, 20 years ago, right, there was Linux and Windows. And at this point, we don't think about Linux. Linux is just everywhere. But Linux is an open source stack. And of course, I mean, the analogies break down as soon as you express them. But that's where I think we need to get to in terms of this ecosystem. We need to get to XG, right? I think the whole numbering system is wrong too. Stacks that are of the quality of a Linux operating system. Now again, I mean, there's more to it, right? This is way more complex, but I think we're at that inflection point where these stacks are actually getting better. Agree, they're not commercial yet, but they're getting better. But we need to advance them. We have flexibility despite all my pain with Spectrum. I see the light in terms of getting more flexibility in Spectrum. So I think we can get there, but it's going to take all these things together to get us there. But I don't see any other way to branch that gap other than open source. The one other thing I'll quickly say is I'm a big proponent of Open RAN and RUs too, but we can't not have SDRs. We need both, right? Because though the RUs are going to give you whatever waveform they are programmed to do, and if we really want to do spectrum sharing, I think we want to go beyond that as well. So.
A quick response to that. Who in the room is from industry here? Who in the room is from industry here? See, that's the problem. So we cannot be talking about spectrum sharing with 5G and 6G if you don't have the people who are building 5G and 6G in the room, right? Because we have to get them to really be part of this process and say, okay, you know, Ericsson, we're going to give you guys a base station, but it's not a black box. We're going to give you hooks that you can change things in there. So it is kind of between the SDR and the open source. And that is the level of cooperation we somehow need to develop with industry if you really want to push
So
this
NRDZCOM4 joint with National Spectrum Consortium with a NOFO with $100 million on the table. Get everybody to work together. I think we're going to need to finish. Okay, one last topic from.
So, Judy Jan from University of Minnesota. So I had point basically add on what the Cobos and what Monisha, right? So I think when we think about testbed, oftentimes we'll always think about the hardware kind of new shining things. But I think what we point out here is also the testbed had to involve all the software development and how that incorporate with hardware. I mean, the other part is related to the data, right? So there's actually a lot of data available. The problem, oftentimes the data cannot be kind of correlated in such a way. I understand end-to-end how that improve the user experience, the application, how you use the spectrum much more efficiently. There's a lot of spectrum there, but it's not being used efficiently. A lot of innovation may coming from the software and the software hardware co-design part, not just getting another spectrum sensors or another kind of mini-wave antenna, which just give you an IQ sample, which I don't know how to use them.
Anything you want to respond to there? I don't have anything. No, sorry, okay, I didn't have anything to respond to that either, thanks. Okay, I think we're going to, we've got a eager hand in the back, all right, from New Mexico Tech. Great, I'm sorry, I didn't. Yeah.
I hope this question is relevant. So there's been various discussions on spectrum sharing, dynamic spectrum sharing testbed, and building this ecosystem that would allow access, transparency, and coexistence, right? But this ecosystem is going to be comprised of academia, DoD, and industry, and they will all participate in this testbed, hopefully. My question is on the data sharing part of all of this, to build on the professor over there, where the norm is usually mostly industry or DoD to stay in your silo. What is being done, or is there a line item in this strategy that, let's say, reaches a consensus on metadata, or you're saying about talking to the community, building a community workshop that will emphasize like a common data ontology? That's my question. Data sharing,
That's
common
for you.
data ontology.
Yeah, that's a great question, and luckily for us, we try to address that in the implementation plan. And part of the key role that we think NTI plays is trying to help establish that data format, that standard data format for the data sharing. It's a role that we were given within the implementation plan to establish for the National Dynamic Spectrum Sharing Testbed. a standard data format and a data sharing approach for the federated network of sites. So answer to your question is that's our plan. And you know, certainly, again, working together, we hope we can establish that standard.
Yeah, so Hong Wei has a question, so we'll get him next.
So use 30 seconds of your time. I just want to go back to some of the earlier discussions. You know, for folks in wireless networking, we know there are certain fundamental limit, right? It's kind of physics. For example, trade-off between delay, throughput, reliability, right? And part of the effort research in the more of the algorithmic theoretical community is understand that limit and try to how to navigate that. Similarly, I think that applies to the testbed. You know, there's different tensions between different dimensions, real reality, programmability, performance, and so on. I think that there's a tension. To some extent, there's actually fundamental tension between these. I think as a community, what we want to do is to figure out how we can, you know, somehow figure out ways to be able to enable different users to navigate into that space. There's no single solution, I think, that's there. As we plan for programs or project, maybe that's something we can work together.
Is that a research topic, figuring out those
I think
elements?
so. There are actually
Okay.
some fundamental research questions to be addressed, right? For example, how do you enable high performance, fully programmable,
Oh, okay.
SDR-based MIMO solutions, right? And there are solutions, there are folks working on those solutions. We just need to be able to enable those efforts and then, you know, from development to deployment and operations.
Okay, thank you. All right. So nobody else is brave enough to keep everybody else in the room for another 5 minutes. We're going to sit here at the room so we don't disturb you. Why don't you just come up and do your goodbyes, and we'll call it a day and the end of the NRDZCOM workshop.
Okay, well, I'll be short and succinct as best I can. So I was sitting here sort of hastily compiling kind of the major thematic ideas that I heard throughout the day, and I kind of came up with 5, and unfortunately my thesaurus wasn't helping me to stick with the theme here. So it's spectrum, sustainability, scope, strategy, and then partnerships was the one my thesaurus was not helping me with. Partnerships or maybe federation. It suggested society or something. Yeah, synergy. I don't know. But really, just really quick, kind of going through the thematic ideas. So spectrum, I mean, we've heard this for multiple NRDZCOMs, getting access to spectrum. We've heard it through DySPAN. We've heard it through Spectrum Week. Getting access to spectrum, managing spectrum, flexible use, right? These are all big thematic ideas that we continue to discuss in these forums. Sustainability, right? Planning for the long term, right? Thinking 3 years, 5 years, 10 years, 20 years. What are the resources? What are the people? What are the equipment? What are the users? What are the use cases that's going to make this valuable over a very long period of time? Scope is still something, interestingly enough, we're talking about. The joke that we used when I was at the Naval Academy and we were just sort of starting these NERDS workshops was, we want a NERDS the size of New Mexico. Why did we pick a NERDS the size of New Mexico? Because it was just sort of a convenient sort of thing to say the NERDS, people wanted a NERDS that was physically large. But is that really true? Is that really what the community wants? We've heard people talk about radiodynamic zones that are of different sizes or maybe that can breathe or things like that. So what really is the scope? What's the scope? What's the size? What's the scope in resources? What's the scope in function? I think these are things that we're all still talking about, interestingly enough, several years into this journey. Strategy. We can't have, I can't not say strategy since we've been talking about the National Spectrum Strategy, but I come back to one of the questions that was asked of the panel, one of the panels. What is the strategy for translating the research and development work that's been ongoing for the last several years into actionable policy, into a working facility, into something that can actually be stood up? What's the strategy for doing that? And then Monisha reminded me about the partnerships, or what did we call it? The society. Synergies, right? Industry, right? Academics, government labs, DoD, our sciences, we've been talking radio astronomy, but Earth observing, right? Those are all constituents that are sort of part of this NERDS ecosystem, and how do we all partner together to bring this vision to fruition? So those are kind of the big thematic things that I heard throughout the day. And these are things that I think and hope that we're going to continue to discuss and to work on and make progress towards over the coming years.
And I have one final word, which is just a request to all of you. How can we make the next NRDZCOM meeting better? Whatever thoughts you have while it's fresh in your mind, send us an email, and we will try to make this a useful way for you to spend your time either online 6 months from now or in person a year from now. So thanks very much for being here, and I hope you had a good chance to talk to everybody at the breaks. That's the most important part of the whole day, right? Okay. Thank you all.
Thank you all.